Hello everyone. Today we are going to solve this question number 724 of LeetCode named as find pivot index. In the last video, we have solved the same question using brute force approach. This time we are going to solve this question using an optimized solution. So we all know in this pivot index question, we have to find the pivot index where the sum of all the elements before the pivot index and sum of all the elements after the pivot index excluding the pivot index value on both of the sides should be equal. So basically what the pivot index demands is the sum of all these three values should be equal to sum of these two values. This is also explained us here by LeetCode. Thus nums of 0 plus nums of 1 plus nums of 2 is equal to 11. Same way, nums of 4 plus nums of 5 is equal to 5 plus 6 is equal to 11. So our pivot index is 6 over here. So to solve this time in an optimized approach, we are going to use concept known as prefix sum. What a prefix sum is, for each value of prefix sum, we will be having uh, the sum of all the numbers till that index. So for a prefix sum of index 2, we are going to have sum of all the numbers till here. So we are going to have sum till this, like 3 plus 7 plus 1 is equal to 11. So we are going to continuously loop through this first array and we'll be having sum of all the elements behind this index, right? So this is a simple formula to find prefix sum. The prefix of I is equal to nums of 0 plus nums of 1 plus nums of 2 till nums of I. This can also be written as prefix of I is equal to prefix of I minus 1 plus nums of I. One thing to notice over here is the first index will have the prefix sum as 1 because prefix means basically sum till itself. So the till itself is included, so we have to include 1, and before 1 obviously there are no values over here, so the prefix sum for first index will be 1. So we have to manually set this one and the rest can be done through loop. Let's go to code this part of calculating pivot index first, pivot array first, and then we'll calculate how we can get a pivot index through it. Okay, so first thing we need is int n is equal to nums dot size. Next we'll need a vector to store pivot the prefix. We'll be having it of size n, and prefix of 0 will be equal to nums of 0 as we saw in the board over here, that prefix of 0 will be the first element. The next can be done through loop. So for int I equal to 1, I less than n, I plus plus, prefix of I is equal to prefix of I minus 1 plus nums of I. Okay, so we have this over here. The next thing we have to do is we have to calculate how can we get left sum and right sum from this prefix array. So to get the left sum and right sum from this prefix array, we have to pick this value over here as a left sum. As we know, the answer for this one is the 6, the third index element, which is 6 over here. So to get the left sum for this one, the left sum will be the prefix just before the index we are checking right now. And to calculate the right sum, what we are going to do is we are going to take some prefix sum of last element. The last element prefix sum is equal to the sum of all the elements till it. The sum of all the elements in this array. Okay, so the sum of all the elements over here will be this one, minus the prefix sum of this array, this prefix sum of the index we are checking. So by this we are going to have a right sum. So let's code that part. So we want a loop for int I equals 0, I less than n, I plus plus, int left sum is equal to I equals 0. If the value of I equals 0, the left sum will be 0, obviously, because the left part of this is obviously 0 here, 0. Or we want prefix of I minus 1. And for int right sum is equal to 0, right sum we will need to calculate the same way as we discussed over here. We'll be needing prefix of n minus 1 minus prefix of I. We are using prefix of I so that we can exclude this value in our calculation, because of this value obviously, because a question demands that the pivot index is not taken in each of these left sums or right sums. Okay, so this way we have the left sum and right sum. Now if left left sum equals right sum, return index. And if we went through the whole loop and we never returned an index, that means we don't have a pivot index. So in that case we have to return -1 as suggested by question. So for this we will return -1. Okay, so everything looks fine. Now let's run this code, and all our test cases are accepted. Now let's submit it. Okay, so this question has an O of n time complexity, so obviously it beats time complexity wise everyone, although it's not very okay. So that was it for this video. See you in the next solution.